it amuses me, so I do things that amuse me. And again, the first year that I was teaching here, I made people code this up. All right, so it's a program that draws pictures, and the input consists of a number n and two drawings. So this is your in this case, this is your n equals 0 drawing, and your n not 0 drawing, your recursive case, is a square plus, what's this little arrow under here? It says take. All right, let's continue because I know there's a slide on. All right, so n equals 0 is the circle. N equals 1 is a square with the n equals 0 inside, right? N equals 2, or memorize what n equals 1 looks like, right? Because n equals 2 is the square with, see this thing here, it takes the n minus 1 picture and it shrinks it slightly and it rotates it slightly, right? So we shrink it slightly and we rotate it slightly, right? So this is n equals 2, and then equals 3, right? And n equals 30. All right, everybody get that? It's kind of fun. I mean, you've seen this kind of stuff before. You might wonder how trees grow, right? I mean, it looks like a tree, right? And what is it? Well, the base case, in this case, is nothing, right? N equals 0 is nothing. N equals 1 is that stem with n minus 1's hanging off of it, right? So n equals 1 is the stem with these nothings hanging off of it. And then n equals 2 is a stem with 1's hanging off of it. And n equals 3, n equals 4, n equals 5, n equals 6. Right? It's kind of fun. This one, you probably have seen, I don't know. I certainly saw it as a kid, right? So what is it? The base case is just the line. And the recursion has no picture. It just takes the n minus 1 picture, shrinks it by a factor of a third, and then draws 4 of them, right? So, right, n equals 0 is a line, n equals 1 is just a triangle, 2 and 3 and 4 and 5, right? And if you would draw n equals 6, it would actually look like exactly like this, because you couldn't see the little difference. And then one thing that's kind of cool about this picture is to calculate how long the line is. Have you all heard about, you take the seashore and you want to know how long it is? Well, if your ruler is of length 100 miles, it will have so many of them. Now, if it's of length a mile, now you're getting a little bit, if you have a length of foot, you get a length an inch. The smaller your measurement, right, the longer the seashore gets to be, right? So that's kind of like this. So we can ask, how long is this path of when n equals n? Well, you take the one of n minus 1 levels, and you shrink it by a factor of 3, right? Remember, we shrunk it by 3, and then we had 4 of them, right? So when you do a length, it goes up by a 4/3, right? I mean, here you can just see this is of length 1, and then this is of length 4/3, right? So everybody kind of follow that? So if you were to have n go to infinity, how long would this line be? It'd be infinite, right? It'd give you this infinite line. And that, of course, is an example of a fractal. All right? this might not have been all my first term. Maybe some of these I gave my second term. All right, so we wanted to find the cheese. Oh, and this was back when this was a long time ago. So this was the only output we could do, and you couldn't put a character in a random place, right? You had to draw it one line at a time. Anyway, we wanted some cheese to find, and so how did we get to this maze? So you start with a room, and then you might see up here is a little door, and then you let's see, you randomly choose a spot in the middle and fill in walls, and then you have friends in each one who fills in the rest, right? So that gave you a maze. Any questions about these examples? Right, it's just showing you some of the things that you can do with recursion. Right, everybody good? All right. That's good. I was wondering what those guys are doing. Is that like some construction, or is it all right, now we're moving over to balanced trees, right? A new topic. So we get the slides.